Okay, in this lesson we're going to start talking about adding and subtracting polynomials. But before we can get into that, we need a few little basics. So first of all, when we talk about a monomial, remember mono is the prefix for one. So a monomial could be any real number, a variable, or a product of a number and a variable as long as the exponents are whole numbers. Okay, so here are some examples of things that would be monomials. 18, the variable z, a negative 4x squared. Even though there's two things there, that whole thing is considered to be a monomial, or sometimes what we say is one term. Okay? When we talk about the degree of a monomial, the degree is the sum of the exponents. Okay? So I would add up all of the exponents on the variables, and that gives me the degree of the monomial. The degree of a constant, okay, for example, up here we had 18, that's what we consider a constant, it never changes. So its degree is 0. And if we have the number 0, 0 has no degree at all. Okay? So the degree of a monomial is the sum of all the exponents of the variables that are in that monomial. If it is a constant, the degree is 0. And if it's the number 0, it has no degree at all. So let's look at a few examples here. State the degree of the monomial. So I have the monomial 5. So the degree, the only variable is x, that is to the first power, so the degree of that monomial is 1. In problem number 2, I've got two variables, an x and a y, so to get their degree, I would add the two exponents together, and I get a degree of 5. Problem number 3, we simply have the number 4. Remember, this is a constant. And a constant has a degree of 0 because it has no variable power. So what I would like you to do is to pause the video, and I would like you to try these 3 guided problems in your notes. Try them, then play the video and see what the solutions are. For A, we've got x and y. They each have a degree of 1, so when I add those two degrees together, I get a degree of 2. In B, 27y to the 4th z, well, remember the z has an exponent of 1, so I'm going to add those two exponents together, and I get a degree of 5. And in C, we have a constant 11, and remember, any constant has a degree of 0. So hopefully you were able to do those 3 problems and get those correct. Okay. We can add and subtract polynomials by combining like terms. So we'll get a little bit more into what a polynomial is here in a second. But just know that by adding or subtracting them, we're really just combining monomials or like terms, things that are the same. Okay. For those of you who don't remember from your previous classes, like terms basically means you're going to have the same variables with the same powers. So in this example, what is the sum or the difference? If I've got 3x squared and 5x squared, then they are like terms because they both have x squareds, so I simply add the coefficients. And I have a total of 8x squareds. Okay? So when we're combining these like terms, remember you're simply adding the coefficients and keeping the variable piece the same. I've got 4x cubed y here in part B minus an x cubed y. So I'm looking at the coefficients. Okay? Remember, if you don't see a coefficient, it's always a 1. They are like terms because they're both x cubed y. So 4 minus 1 is 3 x cubed y. Okay? So it's simply a matter of just adding these like terms together. Okay? So again, I'd like you to pause the video, try these 2 problems in your notes, and then restart the video to see if you got them correct. Negative 6x to the 4th plus 11x to the 4th. They are like terms because they both have x to the 4th. So negative 6 plus 11 gives me 5 x to the 4th. In part B, I've got x squared y to the 4th and x squared y to the 4th. So 2 and negative 7 gives me negative 5 x squared y to the 4th. So we're simply combining the like terms, adding or subtracting the coefficients as necessary. So when we talked about polynomials, a polynomial, poly is a kind of a prefix for many. A polynomial could be a monomial, it can only be one term, or it could be a sum of monomials. It could be several of them being added or subtracted together. And we can name a polynomial based on its degree, which again is going to have to do with the exponents, or the number of monomials, or the number of terms in that polynomial. Okay? And here's a little chart to kind of help you out. Okay, a polynomial that just simply has the number 6. That's a constant, what we call a constant. Remember, a constant has a degree of 0. It only has one term in it, so we call it a monomial. Mono is 1. Okay? 5x plus 9. Well, the degree is 1 because the variable with the highest degree is this x, and that x has a power of 1. So we call that a linear function. The number of terms is 2, the 5x and the plus 9, so there are two separate terms. So we call that a binomial. Bi is a prefix for 2. Okay. 4x squared plus 7x plus 3. That has a degree of 2. With a polynomial, we classify the degree based on the largest power. Okay. So largest exponent. Okay, when we talk about the degree of a polynomial, we're looking at the largest exponent in that polynomial. So in this third one here, that largest exponent is a 2, so its degree is 2, and we call that a quadratic. And we're going to work extensively with quadratics later on in the unit. It has 3 terms in it, the 4x squared, the 7x, and the 3, so we call that a trinomial. Tri is for 3. Okay. In this next one here, we've got a 2x cubed. Okay. And x cubed is a third degree because that's the highest power, and we call that a cubic. There's only one term, so again we would consider this to be a monomial. And the last one we have in our chart is x to the 4th. So 8x to the 4th minus 2x cubed plus 3x. So the largest exponent is that 4, so it is a 4th degree. Okay, once we get past the cubic, we really don't have a specific name for them, so we just call it what it is. If it was x to the 5th, we'd call it a 5th degree. If it was x to the 9th, we'd call it a 9th degree. Okay? There are again 3 terms, so we have a trinomial. If we get anything beyond 3 terms, we just call it a polynomial. Okay? We get past that 3, we don't really have specific values we give it or specific names. So anything over 3 parts, 3 terms, we would just call a polynomial. When we talk about standard form, we want to write these polynomials in what we call standard form. And all that means is that you write the terms so that the degrees or the exponents are in descending order. I start with the largest and then I start working my way down. Okay? So notice in this example I've got a 4, 3, 1, and then a constant which has a degree of 0. So my exponents are going in decreasing order, starting with the largest, because remember the largest is the one that will tell me the degree. Okay. So in example 3, we want to write the polynomial in standard form and then name it by degree and the number of terms. So in A, the largest power is the x squared, so I move the 4x squared to the front, and then the 3x goes next. Okay. The degree here by the number of terms, okay, or excuse me, the degree by the exponent there, the degree is 2. We consider that to be a quadratic. Okay, so that is naming it by the degree. It is a quadratic, and by the number of terms, since there are 2 terms, it is a binomial. Okay. In part B, we find the largest exponent, that's 5x cubed. Notice I have 2x terms, so I would add those together, giving me 11x, and then a minus 1. So here's my degree of 3, we call that a cubic. And we have 1, 2, 3 terms, so that becomes a trinomial. Okay. Tri for 3. So this is a cubic trinomial. So again, here's another guided problem. Pause the video, see if you can put it into standard form, and name it by its degree and its number of terms, and restart the video to see how you did. Okay, the largest degree here is the 2. So the 8x squared goes to the front. The next term would be the positive 2x, and then the minus 3 at the end. Notice that we're always taking the sign that's in front of the term. So the 8x squared had a positive, so it's positive at the front. The 2x was positive, so it's a plus 2x. But the 3 has a negative with it, so it's a minus 3 at the end. Okay. And again, this is a quadratic, okay, because it's second degree, and it is a trinomial because it has 3 terms. Okay, so make sure, did you take the notes and do the got it problems? Okay, because it's not just a matter of watching the video, it's watching the video and taking the notes. The nice thing about the video is that you can pause it, rewind it, so that you can get everything written down. And I will be checking in class tomorrow to see if you did those things. Okay, we'll see you then.